Hello students, in previous lecture we have studied about the few basic concepts about the properties of different geometrical figures and the basic concepts which is related with geometry. Then we have solved the examples which is based on those properties also from practice set 1.1 as well as practice set 1.2. Then see here, most of the geometrical concepts, properties of the different geometrical shapes, figures and diagrams are depends upon logical thinking. There are different properties which is related with the different geometrical figures in the geometry. For example, see here, one of the property, that is, if lengths of two segments are same and equal, that means see here, the length of two segments, that is AB and CD, those are two segments of which lengths are same, that is if it is a 5 cm and CD is of 5 cm. Here length of AB is equals to length of CD, that means here length of two different segments are equal. Then those segments are congruent, that means here segment AB congruent segment CD. Then here, that is the one of the property which is related with the congruent segments, that is if the lengths of two segments are equal and same, then those segments are congruent. That is the statement, that is the property which is related with the congruence of that segments, and this property is expressed using if and then. That means the statement or the property in the geometry which can be written in the form of if and then that property, that statement is called as conditional statement. Let us study about the conditional statements as well as their converse. Then here the statement which is given, that is conditional statement, is given here about the congruent segment, that is if the lengths of two distinct different segments are same and equal, then those segments are congruent. See here, in this statement the if and then word used here, then that statement, that property which is related with the congruent segments which is given in the form of if and then that statement is called as conditional statement. Here in this conditional statement, the part of statement which following if, then that means here, see here, the part of statement which following if, then see here, the lengths of two distinct segments are same and equal, that part is called as antecedent. It is called as Antecedent. Antecedent, the part of conditional statement which followed by if, then that is called as antecedent. And the part which is followed by then, the part of statement which is followed by then, that statement, see here, the part of statement which is followed by then, that statement is called as, that part of statement is called as consequent. Consequent. Then there are two parts of any given conditional statements, that is antecedent and consequent. Consequent, which is the part of statement which is followed by then, and the antecedent, the part of statement which is followed by if. Then we can write the different properties in using if and then form, and which is called as conditional statements. Let us study few properties which is in the form of if and then. That is the few examples of conditional statements. For example, one of the example, see here, if two adjacent angles, if the sum of two adjacent angles is 180 degree. 180 degree. Here comma should be given there. Then those angles are linear pair of angles. Then see here, the conditional statement, that is the property of linear pair angle, is given here. If sum of two adjacent angles is 180 degree, then those angles are linear pair of angles. See here, the antecedent which is given here, that is sum of two adjacent angles is 180 degree, that is the antecedent. That is the antecedent. And here the part which is followed by then those angles are linear pair of angles, that is the consequent. That is the consequent. Then see here, we can give more examples of that conditional statements. Then let us study few more examples of conditional statements. The second one example, if quadrilateral is parallelogram, then opposite sides of quadrilateral is parallel to each other. See here, if quadrilateral is parallelogram, see here, quadrilateral is parallelogram, then opposite pairs of that quadrilateral are parallel to each other. That means here, let us study about this property. If ABCD is a parallelogram, then AB parallel CD and AD parallel BC. Here quadrilateral is parallelogram is an antecedent, and opposite sides of quadrilateral is parallel to each other is a consequent. See here, one more example of conditional statement is, that is, if diagonals of quadrilateral are perpendicular bisector of each other, then that quadrilateral is rhombus. We have to identify the part of antecedent and part of consequent given in the conditional statement. Then we can write the converse of given conditional statement. Then we are going to write few converse of the given conditional statements. See here, the first conditional statement I have written here, that is, see here, if sum of two adjacent angles is 180 degree, then those angles are linear pair of angles. Then if the antecedent and consequent of given conditional statement are interchanged, then the resultant statement which is obtained is called as converse of that given conditional statement. That means we have to interchange the antecedent and consequent of given property. Let us write the converse of those given conditional statements. Converse of above that given statement is, see here, we have to change only antecedent and consequent. Then see here, if see here, the consequent is given here, those angles are linear pair of angles. Then see here, if angles are linear pair of angles, then see here, then the statement we have to write which is given after if in the conditional statement, that should have to write in the converse after then. Then sum of those angles is 180 degree. See here, focus here. Once again, that is, the given conditional statement is, if sum of two adjacent angle is 180 degree, then those angles are linear pair of angles. And converse of that statement is, if the angles are linear pair of angles, then sum of those angles is 180 degree. Then one of the example of conditional statement is given here. That is, if diagonals of quadrilateral are perpendicular bisector of each other, then that quadrilateral is rhombus. Then the converse of this given statement is, if the quadrilateral is rhombus, then diagonals of quadrilateral are perpendicular bisector of each other. Then diagonals are perpendicular bisector of each other. Then see here, the conditional statement is given here. If diagonals of quadrilateral are perpendicular bisector of each other, then that quadrilateral is rhombus. And here in the converse, if the quadrilateral is rhombus, then diagonals of that rhombus is perpendicular bisector of each other. That is about the few examples of conditional statement as well as their converse. Then see here, similarly we can write the different properties which is related with the geometry of different geometrical objects, that is written in the form of conditional statement, and we can write their converse also. Then see here one more example of those conditional statement and their converse. See here, if the number is prime number, then it is odd or even. See here, then converse of this statement is if, see here, the part which is after then is written in the converse after if the numbers are odd or even, then those numbers are prime number. Then those numbers are prime numbers. See here the given condition, the property which is related with the prime number is given here. That is, if the number is prime number, suppose 2, 3, 5, 7, 11, 13 are the few prime numbers. If the number is prime number, then it may be odd or it may be even. See here, 3, 5, 7, 11 are odd numbers and 2 is even number. Then that statement is true. That given statement, that property is true. But see here, if the number are odd number or even number, that means in the converse it is given, that is the number are odd or even, then see 1, 2, 3, 4, 5, in which 1, 3 and 5 are odd numbers and 2, 4 are even numbers. Then if there are odd or even numbers, then those numbers are prime numbers. See here, those all odd numbers are not the prime number. That means here the statement which is obtained in the converse of given conditional statement is not the true, it is false. That means the converse of every conditional statement is not true. See here, in this example, 1 is odd number, but it is neither composite nor prime number. 2 is a even number, it is prime number. 3 is odd number, it is prime number. 4 is even number, but it is not the prime number. That means here in this example, the given conditional statement is true, but the converse of that conditional statement is false or it is not true. Then that is about the few conditional statements and their converse. Then see here, Euclid is one of the mathematicians who gathered the knowledge of geometry in 3rd century before Christian era. That means Isvi San Purva 300 years. That means here in ancient time, that great Greek mathematician, that is Euclid, who gathered the knowledge of geometry which are related with that conditional statements and their converse, and he gave evidence for few geometrical statements. Evidence means he gave the proof for that given geometrical statements using activities, and he gave the proof of those geometrical statements by doing some activities, and those statements are known as postulates. That means Euclid gave the few basic properties which is related with the geometry or geometrical concepts, and he gave the evidences for that. Therefore, those properties, those conditional statements are taken as it is to prove the other conditional statements, and the properties, the conditional statements, the geometrical statements which is given by the Euclid, and that is proved by activities, that are called as postulates. Then we have to remind those postulates of Euclid. See here, those properties, those geometrical statements which is proved by Euclid in ancient time are taken as it is without any proof, are called as postulates. Then first postulate, that is, see here, there are infinite lines can be drawn passing through a single point. If there is only one point, then we can draw the infinite lines passing through it. How many lines can be passed through the single point? See here, like that we can draw the infinite points passing through that single point. That property which can be taken to prove the other properties which is based on this statement. Therefore, that is one of the postulate given by the Euclid. The second one property, that is only one line can be drawn passing through two points. See here, if there are two different points, that is point A and point B, through which we can draw one and only one line. See here, we can draw only one line passing through it. That is the one more postulate given by the Euclid. Then third postulate, a circle of given radius can be drawn having any point as a center. Let me see, if there is a O is a center, any point if we taken as a center, then we can draw circle of given radius. If there are 3.5 centimeter radius is given for it, then if we taking the distance in one needle compass of 3.5 centimeter, then we can draw the circle of radius 3.5 centimeter with any point taken as a center. Fourth one postulate, that is all right angles are congruent with each other. Then see here, all right angles are congruent with each other. That means see here, there is a right angle. There is a right angle. There is one more right angle. Let's see here. One more right angle. As well as there are few right angles are there. See here. That is the right angle. Those right angles are of, when we measure this, it is of 90 degree. All right angles are of 90 degree. See here, that is of 90 degree. This right angle is of 90 degree. This right angle of 90 degree. Then all right angles are congruent because measure of those right angles is 90 degree. And when measurement of two different angles is same and equal, then those angles are congruent angles. See here, fifth one postulate of Euclid, that is if there are two interior angles are formed by transversal on that two lines, line L and line M. There are two different lines are there, of which line T is a transversal. Because of that T transversal, on those lines there are interior angles which is formed. See here, and these are also two interior angles which are formed. Then see here, if the interior angles which is formed because of that transversal, when are formed on one side of that transversal, if those angles are less than two right angles, that means two right angles means that is 180 degree. And if the sum of these two interior angles which is formed at only lies on one side, and it is less than, if it is less than 180 degree, then those lines which is produced, if those lines produced on the same side, then those lines can intersect to each other. Those lines can intersect to each other. Then see here, line L and line M which is produced on the same side where the two interior angles are formed which is less than two right angles, then those lines can intersect to each other. And here, if the two interior angles which is formed on another side of transversal, those interior angles are greater than 180 degree, then these lines, if produced on that side, these can not intersect on that side. Then that is the 5 postulates which is proved by the Euclid, and here we can use those postulates to prove the few more properties, and those properties which is proved using those postulates is called as theorems. Then the logical concept which is used to prove the theorem is called as proof. And if we prove the given statement, then antecedent is known as given part and the consequent is known as part to be proved. There are 2 different methods to prove the theorem or conditional statement, that is direct method and indirect method. Then we will prove few conditional statements in the next lecture by using direct method or indirect method. Thank you.